In this video, we're going to go through the basics of hypothesis testing as well as looking at several different examples. When we're doing a hypothesis testing, we're starting with some kind of a hypothesis, and we test it using mathematics, using statistics. We're going to be looking at both a z-test and a t-test of the mean. This is similar to what we've seen for confidence intervals. We're going to apply a z-test using the standard normal curve if we have a known population standard deviation. If we do not have a known population standard deviation, then we will use the t-test, so no population standard deviation. So basically, if we're given only sample information, which is a lot of the times, then we'll be applying a t-test. I want to show you what some of your tools are. As I go to, let's see, the table F and procedure table. So this is going to be one of your tools. As we arrow down here, this is from our textbook, we've got these procedure tables. We will be looking at both a traditional method and a p-value method. You'll notice that both of them start with identifying a hypothesis. We'll do both a null and alternative hypothesis. You'll see how that gets put together. And then looking for a critical value for the traditional method, computing a test value, and then making a decision and summarizing the results. So you'll understand what all of these steps are, but essentially as we're looking at this, I want you to think of this as sort of an essay. So with our essay, we have an introduction. With the introduction, we're going to talk about what we are assuming, what we're hypothesizing. And then steps 2 through 4, so 2, 3, and 4 are sort of like the body of our essay, where we are working through the math, we've got some supporting evidence, and then finally, step number 5 would be the conclusion or the summary. We'll also be looking at a p-value method later, but for now we're going to focus on the traditional method. As I arrow down here, we've got table F. There are several tables that come along with your textbook, but table F is the one that we'll be using primarily. We've been using it for confidence intervals, but we're also going to be using it, I'm going to circle these other 2 rows here for hypothesis testing. So we're going to be looking at this for hypothesis testing. If we're looking for z values, we're going to use these values all the way down here at the bottom. If we're looking for t values, those are all of the other values here in this table. Okay, lots of information. Let me go back to example 1. So a lot of information here. I am going to talk about the null and alternative hypothesis, sample size, and all of this other stuff. But let's go ahead and just start with example 1. So a national report states that the average amount of money spent on textbooks is $3,262. A student senate feels that their seniors have spent more than this. So they've got a survey of 50 students, and they find that the average spent was more like $3,728 with a standard deviation of 997. All right, as we go through this, I do want to identify some of these pieces. One thing that stuck out was this 50. So 50 is n. So n is equal to 50. That's our sample size. So sample size is n. We do have a sample mean. Our sample mean, so we had this 50 randomly selected students that gave us a sample mean of 3762. So sample mean is going to be our x bar, or you could use an M to denote that. For our sample mean, we've got that 3728. We're also given a standard deviation. We really need to read between the lines here to determine if this is our known population standard deviation or not. Well, here we're talking about the study of 50 students, and from the study, we found a standard deviation of 997. So that doesn't sound like a population standard deviation. It really sounds like that's attached to the 50. So this then would be our sample standard deviation S. So 997. So right off the bat here, we do not have a population standard deviation, which means that we're going to be applying a t-test of the mean. Okay, so really breaking this down, we know exactly how we're going to be testing this. Let's see, what other information do we have? We've got this 3262, and this is from the national report. So that national report is saying nationally the average is 3262. This is going to be our population mean. So mu is 3262. Okay, so we've got that identified, that identified. We need to tackle this alpha, which is 0.05. This is your significance level. So the significance level, alpha, is 0.05. This is going to be the size of one of our tails. Let me put this together, working through that 5-step process. We want to start with step number 1, which is our hypotheses. So we're going to have a null hypothesis. So step number 1, we're going to have a null hypothesis. Our null hypothesis is denoted with an H sub 0. Our alternative hypothesis is going to be denoted with an H sub A. So alternative hypothesis, you do not need to write these words out every time, but just so you've got it, the alternative hypothesis is going to be an H sub A, or you might see that denoted with an H sub 1. The null hypothesis is associated with whatever we're being compared to. We're comparing this to a national report. So our null hypothesis, we're going to assume that the national report is correct, and we're going to go ahead and say, let's say that the mean really was 3262. The alternative hypothesis goes with, in this case, what the student senate is what they're predicting. They really think that it's going to be more than that. So more than is going to be a greater than symbol. So for that alternative hypothesis, we continue to use that mu. We actually think that that average is greater than this 3262. Everything in this null hypothesis is about the population mean. So it's really important that you're using mu throughout and that you're using the population mean given to you in the study. Okay, so we've got our two hypotheses. So our null and alternative hypothesis. I'm going to put this together into a normal curve. So we want to go into step number 2, and step number 2 is to find the test value. So as I'm looking for that test value, I'm going to set up a normal curve. I'm assuming that our mean is correct. So we're going to put mu right here in the middle, 3262. This would have a z-score of 0. So I've got 3262. We think that the mean is greater than, so we're going to go ahead and put this rejection region where anything significantly greater than 3262 would live. Remember that significance level, that 0.05? 0.05 is the area of this significance region. So this is the significance region. There's actually a lot of names for this. So this is our significance region or our rejection region, also known as the tail. The area is 0.05. Remember, the area under the entire curve is 1. So we've got our mu set up there. I know that our sample mean was 3728, so x bar is 3728. It's definitely more than 3262. We just don't know if it's significantly more than. So by creating this 5% rejection area, we're minimizing it being just more than 3262 by chance. We really want to make sure that it really is significant enough, just landing in that little 5% area to conclude that it's significantly greater than. So we've got all of this laid out here. We want to find both our test value and we want to find our significance level. So to find my test value, the test value is going to go along with the sample mean. I can use my, my formulas from the book, but I can also use the calculator to go ahead and do this. Let's do this using the calculator. So I'm going to use my calculator. I'm just going to bring it up here. Let me move it over so it's not in the way. I'm doing a t-test of the mean. So I'm going to go into my stat menu. I'm going to arrow over to tests, and then I'm going to go down to t-test. If I arrow down, I've got 2 sample, which I don't want. 5 and 6 are proportion tests. 1 and 2 are not labeled well, but they are a mean test, and we're doing a t-test of the mean. So I go ahead and choose number 2 and then enter. It asks if we have data. I'm not given a list of data. They gave me the sample mean and standard deviation, so I'm going to arrow over to stats and hit enter. It's asking me, see that mu sub 0? That's the null hypothesis mean. We're assuming that mean is 3262. As I continue to arrow down, it's asking me for the sample mean. The sample mean was 3728. The sample standard deviation was that 997. So 997. N is equal to 50. And this next one, let me arrow back up here, where it says mu, this is our alternative hypothesis. My alternative hypothesis has a greater than symbol. So I'm hypothesizing that the mean is actually greater than that 3262. I'm going to hit enter to select that one, and I'm ready to go ahead and calculate this one. So it gives me a t-value. It also gives us a p-value, which is for a different version of the same test, but it did give me the t-value. So I've got my test t-value here. So my test t is approximately 3.305. Okay, step number 3. I want to know where this lives in terms of my normal curve. So I need to find the value that cuts off that normal curve. So the next one that I'm looking for is going to come off of my table. N is equal to 50. I'm going to use table F. I need degrees of freedom, which is n minus 1. So that's going to give me 49 degrees of freedom. So for 49 degrees of freedom, alpha was 0.05, and if I move my calculator out of the way, I've got just one tail test here. So this is a one tail test. I'm going to move over to my table. There it is. So in the table, I am looking for, let me just move this up here, I am looking for one tail. So one tail 0.05, so I'm going to be looking in this column here. And I'm looking for 49 degrees of freedom. So I'm looking along the left column for those degrees of freedom. 49 isn't listed, so I pick the one larger, which is 50. I am in the second column, one tail 0.05, 50 gives me 1.676. So that's the value that I need for that next step. This is my critical value. So 1.676, let me put that back into my test. And I'm almost done. This is my critical value. My critical value is 1.676. This labels my curve here. This happens to be a t-curve. It labels my curve with t-scores. Let me grab a different color pen. So if I grab a red, this number right here that cuts off my rejection region is 1.676. That's my critical value, so I can call that t sub c. My test value, 3.305, lives beyond that. So my test t of 3.305 lives beyond that critical value, which means I land in the rejection region or in that significance region. Because I landed in the rejection region, I'm ready for my next step, step number 4. That's to state my decision. My decision is either reject, and I reject if I land in this region, reject, or I fail to reject if I don't land in that region. And both of these are relative to that null hypothesis. So I'm either rejecting the null hypothesis. In this case, I found a value that was significantly greater than, statistically speaking, 3262. So I do reject the null hypothesis. So I'm rejecting the claim that the mean was equal to 3262. Okay, almost done. These first couple are always kind of painful because we've got to go through all the steps in the setup. Finally, step number 5. Number 5 is to summarize the results. To summarize the results, I really want to answer the original question. If I come back to my original question, it says, was the student Senate correct? Let's see, what were they claiming? They thought that the average was more. So they thought the average was more than the 3262. So were they correct? Yes, they were correct. So I'm going to summarize this saying, yes, the student Senate was correct. Their claim from that original example, the claim was that students spent more than the 3262. Oh, what, 3262. And because their claim was correct, we're able to support the claim. That'll help with the language that you'll see in the Connect Math homework problems. Okay, this first example, always kind of painful, but we're going to be seeing these 5 steps over and over and over. We state our hypotheses. One is based on whatever we're comparing to, the national average, some kind of a study, some kind of a scientific result, and then we say, okay, do we think it's more than? Do we think it's less than? Do we maybe think it's not equal to? And then we had our test value. I did the test value for number 2. Whoops, I did the test value for number 2, and then the critical value for number 3. You can swap these, it doesn't matter. Test value, critical value can be done in either order. And then finally our decision, which is either reject or fail to reject, and then our summary. Let's take a look at another example. In example 2, we are given a problem that states a jewelry designer claims that women have wrists with a mean of 5 centimeters across. This sounds like a mean that we'll be comparing it to, a mean for all women, so we'll call that mu, the population mean. A simple random sample of 40 women has a mean of 4.97. This is our sample mean, so this would be x bar 4.97 with a sample standard deviation, so this is S, of 0.33. Since we do not have a population standard deviation, we only have that sample standard deviation, we want to do a t-test. So with this t-test, we're going to go ahead and put together our hypotheses, and our hypotheses are based on that population standard deviation. Let's keep reading. Test the claim that the wrist sizes are lower than 5 centimeters at the 0.05 significance level. So we're testing that the mean is lower than 5 centimeters. That is going to become our alternative hypothesis. So we're ready for step number 1. The mean is either equal to, let me put my h sub 0 in front here. So let me erase this. This is going to be my null hypothesis. So h sub 0. We always use an equal sign in the null hypothesis. So mu is equal to 5. And in that alternative hypothesis, it's going to be one of our inequality symbols, less than, greater than, or not equals. In this case, we've got that word lower, so we're going to choose less than. So mu is less than 5 centimeters. This gives us a t-curve to work in, and I'm looking at a rejection area lower than 5. My mean lives here in the middle. That would be where the t-score is equal to 0. And I'm looking at a rejection area that is less than 5, so that's going to be on the left-hand side. I think of that less than symbol as an arrow pointing to the left, and that gives me the rejection region on the left. My rejection area is 0.05, so I've got a 0.05 rejection area, and that is the significance level here. So I can go ahead and just write down over here with my other given information that alpha is 0.05. I'm going to be going through the 5-step traditional method. So if I go to that procedure table Let me just scroll down here a little bit. So if I go to that procedure table, we've got the hypotheses. We're going to find that critical value next, and we're going to use table F to find the critical value. We'll use the test value. We'll find that using the calculator, and then we'll make the decision, which is either to reject or fail to reject the null hypothesis. And then finally, that decision, or the summary, sorry, so the summary will be to answer the original question. So I'm ready to find that critical value. So back to example number 2. Step number 2 is to find that critical value. I'm looking for T sub C, and I'm going to use table F to do that. So table F. In table F, I know that I'm going to need degrees of freedom. So let me go ahead and put that here. So degrees of freedom is n minus 1. 40 minus 1, so my degrees of freedom is 39. I also need the significance level, which is 0.05, and I have a single tail, so I'm going to be looking at the column for a one-tail test. Let's go to that table now. So table F. Okay, so here's table F. We have 0.05 with one tail. That puts me in this column here. And I'm looking for 39 degrees of freedom. So degrees of freedom is along the left. I have a 38 and a 40. I don't have a 39. So I'm going to go ahead and always go up to the next one. I'm going to go up to 40. So 40 gives me 1.684. So that's going to be my critical value. You'll notice that nowhere in the table gives you positive or negatives. So if you look down here at the bottom, it does talk about the positive and the negative tails. My tail is over here on the left-hand side, so I know that I'm going to put a negative sign in front of that T that we've got up above, so I'm going to use a negative 1.684. So we have to put the negative signs in on our own. So 1.684, let's remember that and put that into example 2 here. So I've got my one-tail test, and I know that my critical value then is going to be negative 1.684. That is this value right here that cuts off my rejection region, negative 1.684. The next step, step number 3, is to find my test value. My test value is the t-score that is that marks where my sample mean is. So I'm going to use my calculator to do this. Let me scroll back up to my given information. I'm going to put into my calculator my sample mean, my sample standard deviation, and my sample size to find that test value. Let me grab my calculator. I'm going to go into stat and then over to tests. I'm doing a t-test of the mean. If you look down here to 3 through 6, we've got 2 sample tests. I have 1 sample. 5 and 6 are proportion tests. Mine's a mean test. So I'll go ahead and hit enter. I do have stats. I wasn't given a list of data. My null hypothesis gives me a mean of 5. The sample mean is 4.97. Sample standard deviation is 0.33. Sample size is 40, and my alternative hypothesis uses less than. So if I just check here, the hypothesized mean is 5, sample mean 4.97, sample standard deviation of 0.33, sample size is 40, and I've got less than highlighted. So I'm ready to go ahead and hit calculate. And it confirms my alternative hypothesis, mu is less than 5, perfect, and it gives me that test value t. So we get a negative 0.57. So if I just scroll up here, negative 0.57, let me just shrink this down. So it is negative 0.57. That lives over here, so negative 0.57, and this is for our sample mean of 4.97? A lot of 7s going on here. Yep, 4.97. So I'm not falling into the rejection region. I am in the fail to reject region. I am close enough to the hypothesized mean to say that it's not significantly lower. So step number 4, we fail to reject the null hypothesis. And if we look up above here, that means we're essentially favoring the null hypothesis. So to answer the question, we do not have enough evidence to support the claim. The claim was that the risk sizes were actually lower. So we would say there is not enough evidence to support the claim that the risk sizes are lower. So I'm just going to say that the sizes are lower than 5. So as we look back through and kind of do an overview here, we were not given a population standard deviation. So that meant that we were applying a t-test of the mean. Our null hypothesis had the equals like it always does. The alternative hypothesis chose one of our inequality symbols, and we chose less than. Less than points to the left, so I knew to shade in my rejection area on the left tail of that curve. We found the critical value using table F. We found the test value using the calculator, and we compared those two. The test value did not fall into the rejection region, so we failed to reject, and our conclusion, our summary, said that there's not enough evidence to support the claim that the sizes are significantly lower. Let's take a look at example number 3. So for example number 3, we're looking at M&M weights. We've got a sample of 19, so I can start to identify these pieces I need. So 19 green M&Ms has a mean of 0.8635. This is my sample, which means this is my sample mean. So X bar, or M, is 0.8635. Assume the population standard deviation. We're given a population standard deviation this time, 0.0565, which means I'm going to be able to use a z-test this time, a known population standard deviation. Okay, more information. Use a 0.05 significance level, that's my alpha, the size of the rejection region, 0.05, to test the claim that the mean weight of all green M&Ms is 0.8535. Okay, so let's put this together. So I've got my hypotheses. We need a null hypothesis and an alternative hypothesis. As I read through this, we have a sample, and we found 0.8635 to be the mean weight. We've got a population standard deviation, and we're testing the claim that the mean weight of all, that would be mu for all of them, is 0.8535. So what we really have here in the second sentence is the null hypothesis. So mu equals 0.8535. For the alternative, we know that we're going to use not equals, less than, or greater than. We can't use the number to determine that. We just have to read if there's any kind of bias. Are we looking to prove that it's less than? Nothing here gives me that. Are we looking to prove that it's greater than? Okay, we did show that it's greater than, but nothing says we think it's greater like in that first example. So the best choice for the alternative hypothesis is the not equals. If it doesn't clearly say we think it's more, we think it's increased, we think it's better than, then we go with the not equals. So this is going to be not equals 0.8535. A lot of times, deciding how to put that alternative hypothesis together can be the toughest part. Now I'm ready for step number 2. I've been doing my critical value as step number 2, so let's go ahead and just continue with that. This time I'm looking for a critical z value. I'm going to put my normal curve together here. My hypothesized mean of 8535, mu goes right there in the middle. These are going to be z-scores. 0 will live here. I do have a rejection region of 0.05. 5% of the normal curve is my rejection region, but with my not equal sign, I have a two-tail test. Okay, so not equals, now it's going to look like a confidence interval. I'm going to take that 0.05 and I'm going to split it up. So these areas together equal 0.05, but really I've split them into 2 for this two-tail test. Okay, so as I work through this, let me just erase these so we can keep everything kind of clean. So as I work through this, or greater than, I want to find that critical value. So I'm ready to use my calculator. Let's go ahead and grab the calculator. And let's grab the correct test and put the values in. I go over to tests. I do want the z-test this time because of that known population standard deviation. I don't have a list of data, I do have stats, so I start to arrow through. U sub 0, that was the 0.8535. Notice since we did a z-test this time, it's prompting me for the population standard deviation, so I better have it, and I do. 0.0565. Sample mean, my sample mean, I just need to move this guy out of the way a little bit, 0.8635, 0.8635, and we had 19 in that study. And we're using a two-tail test, so I select not equals. So 0.8535, 0.0565, man, a lot of decimal places, 0.8635, and 19. So I can go ahead and use the calculate now. So I've got everything selected. I calculate this. Notice how it confirms your alternative hypothesis. That's exactly what my alternative hypothesis is. It's nice. Okay, so I've got that. This also gives me my critical z value. So that critical z value from the calculator is about 0.7715. So let's see. Remember, this isn't going to give me positives or negatives, but it is a two-tail test, so I do know that when I do my next one, it's going to be positive or negative, but this one was bigger than. So the z-score for that larger sample would be a positive 0.7715. So that one's going to be positive. Okay, let's go ahead and get rid of this guy, and we're ready. Step number 3, we're ready to find the test value.